Hello everyone, this is Will Wilson. I'm recording this video as an addendum to a previous video I recorded for week 1 in Cyber 130 at University of Phoenix. There's been some questions and discussion boards from a few students who are working on getting started in week 1 and having some issues with the format of zyBooks. I'm going to overlap with some of my other videos. Depending on how you found this video, you might not have seen those, but this is meant to go along with those videos and not replace it. So I am going to overlap a bit when I start discussing this. So to start with, zyBooks, interactive grading. It's got some cool features in it, like the fact that you get immediate feedback when you submit something. It tells you what you got wrong, but you have to figure out how to read that. Not everyone learns by reading and doing. Some people are better with videos and things that are a little bit more tangible than just reading an overview and then doing an example. So one of the places that zyBooks I think could use a little bit of improvement is it doesn't really have videos to walk you through. It gives you some overview reading, pretty light reading, not too much, and then you just jump in by answering questions and learning by figuring out the answers to these questions and doing their participation examples. So for students who don't know anything about programming whatsoever, that can be a little bit confusing. I think an interactive session is better where I can discuss it with the students and see what they're not understanding and get them a point of understanding, but everyone has different work schedules and obligations in their life, so sometimes it can be difficult to get these interactive sessions going. So in general about programming, a computer is like a small child. It only knows exactly what you tell it to do, what you tell it. You have to be extremely specific. You can't give it generic instructions and have it figure things out. When you get to some advanced functionality, like when you're talking to Siri and you're like, well, I can just ask Siri this generic question, she figures it out. That is based on layers and layers of software where some human had to program it in, program voice recognition, and create all these different ways that she could understand a sentence. So at the end of the day, some programmers did a lot of work to make it so she could understand when you say, hey Siri, what's the weather today? We're starting at some foundation.
Raining and 79 degrees.
We're starting at some foundation layers. For those who are cyber majors, you might say, okay, what does this have to do with cyber? What it has to do with cyber is we need to understand the basics of input, output, and processing before we can really get to writing cyber scripts. The class that focuses on cyber is actually Cyber 135. In that class, we move from these generic foundations and start actually doing programs that have something to do with information technology and cybersecurity. So what do I need to do? Every program that is useful needs to be able to have a way to get data into it. Sometimes the data is from asking a user. The user types something to the keyboard, says something, it has to get data into it. Sometimes it comes from other sources, various sensors out from other programs. So for the example, you might have a digital thermometer of some sort, and the input into the computer would be how that sensor reads in what the temperature is. Then it does something with it. You have to process the data. So what am I going to do with this? It doesn't do much good if it doesn't do anything with it. This is the meat of most of our programs, is the processing. In our first week, we do some input and output, and we don't focus too much on processing. In later weeks, the processing is going to be the meat of it. One thing I want to point out while I have the table of contents open before I move on to the next section is this cool feature that says print chapter. For those new to programming, when you get to the end of chapter exercises, I recommend you print the chapter and print a PDF. Because it's an interactive textbook, it can be difficult when you print the chapter or when you're trying to go back and forth and doing the homework and go back to refer to the reading. And so if you print this, hit a print, I'm in Chrome, so I have the option of printing it all to a PDF. So That's just my thoughts of something that makes it easier when you're trying to refer back to the instructions. A lot of the stuff in the end of chapter labs came directly from the reading. I noticed in this session, there's been a lot of changes from the last time I did this class. So I'm still going through it and saying, okay, what exactly has been removed and what's been added. I think we've added back a lot of the math in week 1. But I'm sure that most of it looks like it's all still in the reading. So input and output. The basics of input and output are the input statement and the print statement. There are other ways to get input and output, but these are the main ones. The most simple print is printing what we call a string literal. That means print exactly what I tell you to print. You say print, open parentheses, quote, what you want to print, close quote, close parentheses. So this doesn't have any variables in it. It'll always print exactly this. This program is not what I'd consider a useful program. It prints the same thing every time. No matter what, every time you run it, it'll do exactly this. It doesn't do much. In the next example, it's showing you how to override the end. So instead of ending the line with a new line, it's saying I want to end it with a space. Then when you look at the participation activities, these are to reinforce some things to say, okay, now I read it, do I understand it? So what prints welcome with exclamation mark? 2 of these have errors. This one doesn't, the first one doesn't have quotes. The second one has inconsistent quotes. It has a single quote on one side, double quotes on the other. The third one is the only one that works. Next one says, which pair of statements prints the output on the same line? So we need to override the default behavior of print so it doesn't have a new line at the end. We want to have the same line. So we're going to change the end behavior to space. And to make it work out, the last one doesn't work because there's no quotes around no access. And it has this extra n equals at the end, which we don't need for the second line. The first one doesn't override the end, so it's not right. So the middle one is what's right. It has the quotes are right, and it overrides the end on the first print. So after the first print, it does a space. The second print prints no access, and then a new line. Not too exciting yet. So in this example, we actually have a variable. A variable is a container. Just think about it as a box that you put whatever you want in, and then when you want to pull something out, you just pull it out. In this case, we're saying the variable named wage, the box named wage, we put the value 20 in it. And now we want to print wage, we're going to pull out the variable 20. So in example 2.3.3, you're going to print wage, colon, and then it has a comma here. This comma is going to put a space in the print and then print the contents of the variable. So this is going to say print wage, colon, space, the number 20. And then on the next line, it'll say goodbye. And as this hint says, don't forget to use the commas. If you want to explicitly print a new line in the same statement, use the \n. If you want a tab, use \t. Now I'm trying to scroll down until I find something with some inputs. Until we get inputs, it's always going to print the same thing. So let's see if I can find inputs. All right, so now searching for the word input in here, I get down to where we have the input function. The input function gets the input from the user. When we're using Zybooks, it doesn't really get it from the user. It gets it from the Zybooks grading script. It's going to pull in whatever input is provided by the Zybooks grading script. Some students are already saying they're trying to use PyCharm or similar things to test out their scripts, in which case, when they're using that, it really will be input from the user. It'll pause the program and you execute it, and then a little box at the bottom, it's going to want you to type some input. And when you type it and press enter, then it moves on to the next line. So in this case, best friend equals input. That's going to say I want a string from the command line from the user that I'm inputting. The input is always a string. For those who've already started your exercise, you might say, well, I've been using integers, I've been using floats, and a float is just a decimal number. Why are you saying it's always a string? It's a string when you pull it from input. When you change it to something else, you're casting it. So in example 2.3.7, we want this to be an integer. We want it to be a whole number. When you do input, open parentheses, close parentheses, you're getting a string. Now let's say the string is the character 3 and then the character 7. When we say cast this to an integer, it's going to say, okay, I recognize that those are actually digits represented as letters, but I'm just going to translate it to 37 so I can do math on it. So you wrap input in something like int or float so you can convert it to various number formats. So with that, I'm going to do a couple of the basics. I skipped over these, I believe, in my last lab, but there's been a lot of questions on it. The low default template, just because I've already done these. So this one has some very explicit directions. If you follow the directions verbatim, you should get pretty close to getting the answer right. It's saying it wants user num squared. In the directions, it says change the plus to a star because the mathematical definition of squaring number is a number times the number. And the star means multiplication. A common mistake might be to use like a lowercase x because that's what we use when we write multiplication on paper. But in computer programming, we use a star. We don't use a lowercase x. So per these instructions, we change this to a star. This wanted you to go through a progression in making these changes and seeing how things change. So let's actually follow the directions a little bit better. So the direction says, I believe, submit it. And let's see what happens when I submit it. I'll get 0 points, probably, and why? So the first thing I see is your output is 4, and then it has a yellow box here. This empty yellow box means I've got a space that it's not expecting. If it had a yellow box with something in it, that's what we printed that it didn't want to see. If it doesn't look like it has anything in it, it's a space. But it expected this 4 and then this weird character. This weird character, the little arrow, means line feed carriage return. So it says I expected to see a new line, but I didn't see it. Instead, I saw a space. So per the directions, let's fix this and say, all right, to print a new line. So we're going to make this a new line. We can make this a new line by either changing this to the \n that we learned about in the earlier section. But because the \n is the default behavior of Python for a print statement, we can just get rid of this end equals. We don't need an end equals to override the behavior. So we're getting rid of this end equals, and we're just going to let the default behavior happen. So now if we run this, we can say, okay, I passed this test. I no longer have this extra character, extra space I wasn't expecting, and I no longer am missing the carriage return. It started with an input value of 2 and output of 4. We got points for that, and that's what it shows in the example, I believe. The problem with this is 2 plus 2 equals 4 and 2 times 2 equals 4, and that's why it passed a single test. The next test is it inputted 24. We have 12, and again, it's getting its input from the grading script. One of the biggest questions I get that takes a while to click for a lot of people is where are these numbers coming from? The people who created Zybooks put in these numbers to test your script to make sure your script is doing what the directions say and not just matching the single example. They want to make sure that you're able to handle input that changes and provide the output relevant to that input. So if the input's 12, 12 plus 12 is 24. That's what you did. What we did, it wants 144. 144 is 12 times 12. So following the directions, now let's change this to a star. And submit for grading. And notice when I was doing this, it kept saying my score was 3 out of 3, even when I had it wrong. Because I got it right at one point, it kept my score there. So now I see I got all tests passed. And even cooler, I can see the progression of my various attempts. I encourage you to use submit mode in a lot of your exercises, even when you're having trouble, because if you get stuck, you can say, hey, I can't figure this one out. Can you take a look at what I did? And I can go in and go to lab statistics and submissions. And if I click on this drop down, I see a list of every single student. And I can see everything you submitted. For privacy reasons, I'm not going to pull that up in a recorded video, but it's something we can do. So notice here it says the top score is 3. That's a max score. Makes sense. Average score is 2.71. That means that some students didn't get a 3 on this. And with 41 people submitting, that probably means a handful of students who submitted it probably only got 0 or 1 point and didn't do the entire exercise. Again, I don't want to pull up the stats right now. So let's do 2.13, interleaving input and output. This one has had a few discussion board posts. It tosses in an error, and I think I briefly discussed this in my previous video, but I'm going to cover it again. Maybe just by the random variance of what day it is, the way I'll explain it today will make more sense. They added this one because of a common error students have. And a lot of this was fixed by Zybooks rewording their exercises. Sometimes in the Zybooks example, it'll show something like, it'll tell you to enter X, and then under it in the example, they'll have like the number 5. And then they'll say X doubled is 10. There was some confusion in past classes about this format, and a lot of students were saying, oh, okay, you're entering X from input, and then they would go back and print this value because it showed it in the example. So the purpose of this exercise is to show you that you don't always want to do that and how to identify that error. So it starts with, let's just print this. I'm going to load the default template. And right here in the default template, it says student mistakenly is echoing the input to output to match example. And as I'm going through this, I think I actually covered this in a non-recorded video, so it might not even be in my recorded video. This might have been an interactive tutoring session I had last week where we discussed this one. So I apologize if it isn't actually in my main week 1 video. So in the default template, we are printing enter X. And after we print enter X, it says X equals the integer of the input. So I already gave you this. This kind of amuses me that they did a print beforehand, but we haven't learned about the prompt and input yet. Realistically, you could say enter X in here, and I don't want to cause too much confusion, but this is, basically the same thing. This is prompting them for something with input. But since that's not part of the example, I don't think we're going to learn that until like week 3. Let's just stick with what they have. So they're saying print enter X. It's asking you to enter X. You enter what the X value is, and in the case of Zybooks, it does it for you. Let's say I want to do it right here. I'm going to do it in develop mode and run the program. So it printed enter X, and then it outputted X because I said print X. And then it outputted X doubled is 2 times X. So in this case, we did the math in this print statement. So 2 times X is 10. The problem is we don't want to actually print this. If you're having trouble figuring out what it is that's causing the print of this X, they've given you a couple hints. One is right here, it has a comment, it says, student mistakenly is echoing the input to the output to match the example. So if you can't if you're not at the point yet of understanding Python where you can figure out what each statement does, this is a big hint telling you this is the statement that doesn't belong. But it is really important to understand what each line does, because you're going to make errors in your scripts. That's a given. I make a lot of errors. I've been programming for 30 years, which it's kind of scary to actually say that out loud. And I still make constant typos, logical errors. You're in a hurry, you don't think something through. You're going to make errors. The key is knowing how to fix your errors. So let's move it to submit mode. We submit for grading. The grading script will say, I had this 3 in my output, and you see it has the yellow as this 3 in the line feed. It's not expecting that. So it's expecting this without it. So you have something that's not expecting your output. And we need to get rid of that. So to take apart the program, print enter X. That literally prints enter X. X equals integer input. That gets this input from the user. Print X now, that's saying, okay, whatever the value is of X, print it. Print X doubled is 2 times X. That's going to print literally X doubled is, and then whatever the value of X is times 2. Now, since it's telling you that we don't want it to print this value of X here, that's extra, we should know, get rid of this line. You can either delete the entire line, or you can put the hash symbol in, the number symbol in to comment it out. Now in submit mode, I hit submit for grading, and I passed the test. Let's see if I can do maybe one more of these. So I already did this one of my other. Let's look at divide by 0. Since I've got 10 out of 10 on this, that probably means I already did it at some point. Oh, sorry, I just want divide by X. Sorry, let's not even talk about divide by 0 yet. That's for a future session. I think I did this in an interactive non-recorded session, so I'll discuss it again here for my recorded session. In this one, it doesn't give you much to start with. It just says type your code here. So we have to look at the directions and say, okay, what do we need to do? It gives you this hint, but we need to get to that point. We need 2 inputs, and it suggests calling them the inputs user num and X. We can call them whatever you want, as long as it's not a reserved word. But to be safe and make it simple, let's call them user num and X. So I'm going to do the input, change it to an integer. I've seen some examples where a student uses the same variable name twice. If you do that, it'll take whatever you input and assign it to the variable. So let's say you did user num, and then you did user num again. In this case, whatever is the first input becomes user num. And then whatever the second output is, it's going to take out whatever's in the box of user num, throw it in the garbage, and supply the new value for user num. So we want to make sure the variable names are separate because we don't want to throw out what's in the box. We want 2 separate boxes. So now we did step 1, write a program using integers, user num and X as inputs. So they're integers, and we're going to output the user num divided by X 3 times. We can do this a few different ways, but I like to spell things out. So num1 equals user num floor division X. It's telling you right here to use this floor division. Floor division will say divide user num by X, and whatever the remainder is, just throw it away. We're not rounding or anything, we're just throwing it on the floor. This example, everything divides cleanly, so you can get the 2002 to work just fine if you don't do floor division. So let's do it wrong at first, and let's see what happens. So now num2 is going to be num1 divided by X. So I got num1 by doing user num divided by X, and then whatever the answer was here, let's say I divided 2000 by 2, the answer is 1000. So now I'm going to say, okay, what's 1000 divided by X? So now I'm going to do this number here that I got from the first division, and divide it by x again to get the second number. We need to do it 3 times. Now, number 3 is going to be num2 divided by x. So I got the original number, divided by x to get the first thing I'm going to print, divided by x to get the second thing I'm going to print, and divided this by x to get the third thing I'm going to print. Now let's print it. I can print it simply with num1, num2, num3. So I mentioned earlier in the video, if you just do a comma in your prints, that makes it that gives it a space. Let's do submit mode and submit for grading. Oops, my output had these dots here because of the type of division I did. So that didn't quite work out. I can do a couple other things here. I don't want to complicate it too much, but let's see. Maybe I'll do a quote. Make sure hopefully I got the formatting right on this. Let's see what happens here. All right. It didn't like that I used D. We're going to expect it at most 2 arguments. And got 3. Oh, hold on. It doesn't like the code D in Python because it says unknown format code. In some languages, D is an integer. I was having a brain lapse for a second trying to remember what I could use for integer in Python. JavaScript, Java, C, it's D. Let's do this. Let's try what happens here, 0.0f. We're going to learn all about format in a later module. Let's see what happens now. All right, so I did 0.0f, which is saying I'm taking this floating point number. When I did this division, I made them floating points. And I say I want 0 decimal points. Again, we're going to go into formatting later. My first test passed because everything cleanly divided. My third test also passed. My second test failed, and the way it failed, I think, is a reasonable failure because of the way the instructions are written. If it didn't have this hint right here to say use floor division, I think this is completely reasonable. The first time I saw this exercise, I don't think this hint was there, and they added it. Because I saw a lot of people submitting pretty much this answer that I have right here, where they rounded it to an integer at the end. In this case, we want to round it down to we want to use a floor to knock it to an integer after every single division. Say, other than the hint, you really have no way of knowing that it should use the floor every single time. So now let's change it to floor. And I'm going to get rid of this format because we really don't need it when we're using the floor. I'm going to keep an error in here that I just made just to show you what it looks like. So now it's saying your program produced no output, unmatched parentheses. So unmatched close parentheses, I have an extra close parentheses that wasn't matched anywhere. So it's saying you're closing something that was never opened. That's actually an easier error to catch than an unmatched open parenthesis. If we have an unmatched open parenthesis, it'll often tell us the error is somewhere wrong. Unexpected end of line, end of file while parsing. When you have unmatched open parentheses, it'll usually either give you an error on the following line, or if this is the last line, it'll say something like unexpected end of file while parsing. So let's fix this and submit it. All right, now I have 10 out of 10. I'm going to go ahead and stop this video because I'm going to have an interactive session here in a few minutes. Hopefully this clarifies a few other issues. If not, for those who are watching this and need help, shoot me a message and we'll see what we can do to get an interactive session that works on your time zone. All right, have a good day.